Larry BL here, and create a couple intros into the charging system. Now we're going to be talking about a specific alternator, which is the dual mode alternator. And what I've done is several separate segments walking up to how this operates with demonstrations and everything. I'll try to put all those together into one video, so it may be a little bit more lengthy, but to get the full explanation of how the dual mode alternator works, this I think may be the best way to go instead of creating 4 or 5 different segments. So I'm going to give it a try. I'll include this in the beginning, so hopefully it won't make it too much longer. Thank you for your attention. Hello, Larry BL again, and we're going to demonstrate a charging circuit for a battery, okay, using a diode. So what I have here, a diode is a one-way device, and in the next episode we're actually going to show how that actually works. But for now, to create or to change an AC current such as your stator generates to DC, you have to have an inline diode, okay? That only allows the positive side of the AC circuit through. So I have connected up to this 12-volt battery, and if you notice it's kind of weak. I'm showing 10.7 volts on the battery. So what I'm going to do is go ahead and clip the positive wire to the diode, and we'll watch the voltage now, and it's rising to 13.3, 13.38, and now this is an unregulated circuit, but because of the diode and the battery, it will self-regulate. It is possible to actually overcharge a battery, but for this particular circuit, even though I am running 15 volts AC, there is some resistance drop across the diode, okay, and you actually lose about 1.2 volts in the diode, and it is charging the battery. So this is typically how your stator works, generating an AC current, flowing through a diode, converting it to DC, and you now have your 13.5 volts charging as your engine's running. Next we'll demonstrate why the diode is a one-way circuit, again using the battery in this setup. Another function of the diode in your charging circuit is to prevent the battery voltage being backfed into your stator. Okay, at this time I have the transformer turned off, so that would simulate that your engine is turned off, but your battery is still connected to the stator through the diode. If you notice, I have 11.1 volts. I got a kind of a weak battery, but I got 11.1 volts on this side of the stator, and on my other multimeter I've actually set it to the 2.5 volt setting. We will put the terminals across, and this is kind of hard to do with one hand, but there we go. So I am now touching on the opposite side of the diode and moving the connection, and as you can see, the meter is not moving at all. So what happens is the diode is preventing the positive current from flowing back through the circuit. Whenever the transformer is turned on and we present the diode with a voltage higher than 10.9 or 11 volts, then the positive current is allowed to flow through the diode in this direction. The battery positive voltage, when the transformer is turned off, is not allowed to come back through the diode in this direction. Hope that makes sense. Okay, Larry BL again, and this experiment will demonstrate the one-way properties of a diode. So what I have here is we have a DC battery with the positive flowing through a diode connecting to a light bulb, and the other side of the light bulb will come back to the negative side of the battery. Okay, so the current is flowing through the diode in this direction. Okay, so if I take and reverse the terminals of the battery, and we put the negative and try to flow the negative through to the light bulb, absolutely nothing comes through. The diode is completely blocking the negative current trying to come through this way. Okay, so what happens on an AC signal, as a positive and negative signal hits this diode, it blocks the negative side of the signal and just lets the positive current through. That's a simple function of a diode. That's how it's able to convert AC current that's generated by your stator to DC current to charge your battery. Okay, for our last experiment here, what we are showing here now is the dual mode alternator, which has a inline diode coming off the red wire for your charging to the battery, and a black wire for the AC for your lights. So what we have here is we have the transformer with the 3 wires. Well, you probably wonder, where's the third wire on this stator? Well, the third wire is actually where the stator is split right here, and you see there's 2 windings that's grounded. So what we essentially have is 2 separate coils that are grounded to the common chassis. So one coil is providing AC power, and the other coil is providing AC power being converted to DC. So what do we have here is the center tap wire is providing our ground. Okay, so as we come out of the transformer now, the ground is common to the battery and the light. On the AC side, I'm directly connected to the light. So yes, AC can run a light bulb. Does it every day in your house. And on the DC side, we are running through a diode, which now converts the AC to DC, and is being fed to the battery, which I am showing 13.3 volts for charging on the battery. Okay, by removing the charge circuit on the battery, you'll notice that the battery is starting to get a better charge because we started at 10 volts, but it's an old battery. But for all intents and purposes, this is showing how the dual mode stator can be simulated on the workbench. We'll move on to the next mode. Thank you. Okay, Larry BL again, and this will be the final episode for the dual mode stator. The dual mode stator rides underneath your flywheel, and you have magnets inside your flywheel. As the flywheel is spinning around the stator, it generates an AC current. There's actually 2 different size, so you need to, if you on your magnet size, you might want to get the manual if you have to replace your flywheel. But moving on, what we've talked about on your stator is it shows the coil here with a ground. We've already identified the ground, so there's actually 2 separate coils. On the black wire coming out goes through a headlight switch and powers your headlights with AC current, and on the other side of your stator coil it comes through a diode, which comes through normally an amp meter in through an ignition switch, and eventually makes it down to your battery to charge your battery. Sometimes your charging circuit comes directly to your solenoid, or alternately it can be routed directly through the switch to the battery. So this is basically your 2-wire circuit. A lot of lawn tractors use this type of setup. This is the one I would caution that if you try to run LED tail lights, you would have to add a second diode in the circuit to create the DC for your tail lights. That could either be added at the tail lights. Some LED light bulbs have diodes in them, but most of them are designed to run off of a typical 12-volt DC. This particular setup runs an AC circuit for your lights, so you would have to use caution using diode or LED lights. So that'll wrap it up for the dual wire stator. Hopefully I didn't beat it too much to death, trying to demonstrate how the diode operates to create the DC from the AC. And we will see about moving on to the next episode of talking about the dual diode circuit, which is similar to this. There's 2 separate diodes inside this. Both my garden tractors, my Craftsman garden tractors, use that setup. We'll talk about it next. Thank you.